Today we're going to go over a few details on the bearings and things going on as far as how to assemble this motor on the bottom end. We're just going to go over a few of the details. First we got to get to cleaning. All this is just from the fins, the outside fin tube area of the radiator. That's where I was blowing through the center of the core. Yeah, that stuff gets pretty nasty over 100,000 miles. This one's actually fairly clean compared to most, but it's a Corvette, so it's a summer vehicle more than anything. Never really sees winter, so yeah, that is a lot of dirt and debris, considering it's a city vehicle with 100-some thousand miles on it. As you saw just now, I was cleaning out the oil coolers on that radiator, and obviously you got to clean out the engine oil cooler really well when you're building a fresh motor. Transmission I cleaned out, but I didn't spend a ton of time on it. But I did really do a good job of cleaning the engine oil cooler because I want to make sure that nothing happens as far as metal from the cooler from the previous motor getting into my build that I have now. Alright, the camera's battery died, so I missed pulling the bearings out completely. However, I wanted to show you something with the cam bearings. Now, normally I pull the cam bearings out before I send the block in. I forgot. It helps clean things out a little bit. But I did want to go over a couple of things with you related to the cam bearings. I should grab the new ones. Okay, so we have, these are all the factory bearings. I did not keep them in their correct order. I just let them drop to the floor. I threw them on the floor after I was done pulling it out. The install and removal are pretty much the same, just reverse. Start at the back, put them in, but start at the front, pulling them out. And you can see the special tool I have here. This is just for cam bearings. It's got a anvil type thing on the end here, and pull it off quick. So it's got these little paws. You can see how they separate like that, and that spreads out when you tighten this down. In fact, this one's rubber piece is kind of moving where it's not supposed to. There we go. But there's 4 paws here, and then there's 4 paws here. When you put this on, you want to line them up so that the paws are, the gaps in the paws are in the same clocking or area. If you don't, you will break the bottom section of paws. So there's that. There's all kinds of different sizes. Lots of different sizes here. So you can do pretty much any cam bearing within a reasonable size. Now there's ones for bigger, heavy equipment, but anyway. Okay, so here is the factory style cam bearing. One thing I'm going to notice right away is look at the width. See how much wider these are. These have a lot more surface contact, so they're able to hold up better to stress. These ones are much smaller. Not only are they smaller, but they have the seam. So these are a seamless bearing. These ones have a seam. The seam here also damages the block a little bit. I don't know if you can see that. The seam here kind of like destroys it on its way in and out on occasion. Not all of them are like that. This one I could feel. It's got a nasty ridge here. So this is bearing number 1 apparently. I guess they number them. Let's see here. Bearing number 1, bearing number 1, 2, 2, 3. Okay, so what we have is 1 and 5. Yeah, 1 and 5 are the same. I just know this from experience. If I look on here, I'll be able to tell. And then 2 and 4 are the same. So 2 and 4. So this would be the correct order for them. Now the only difference with the cam bearings is the outside size of this. I'm not sure why they did it, but for some reason they have done this for years and they still do it today. They make them different sizes on the outside. If anybody knows the reasoning, please leave a comment because I'm curious myself. For some reason they have these two the same, and then this one is it's a separate size. So we'll go ahead and toss these aside. Now the replacement bearings, not only are they wider, but they are also coated. Okay, so you see how it has that kind of like a Teflon color to it. They are a coated bearing. I prefer using these coated bearings. They're a little more slick, and then there's less chance of any kind of issues showing up when you first fire up the vehicle if it's lacking lubrication or something. So the oil hole size, much bigger on these. These do not have seams. They're just a better overall quality bearing. These seamed bearings, I don't like them. They're basically a flat piece of steel, and then it's rolled and crimped together. And the sad part is I can actually feel this inside section where the seam is. It feels pretty jacked up, to be honest. And that's not cool. So these factory bearings, this is one thing from GM that is just a piece of crap. These are Durabond CHP 25T. It is a good quality cam bearing. It's probably the only one that I really truly recommend for these motors. Now, the first thing I'm going to do, all the ports are opened up, and now that I remove the cam bearings, all the oil ports are available as well. So I'm going to take the time and do some brake clean and air to blow out all the oil ports, make sure that there is no aluminum trimmings from, for instance, milling the surface of the block, deck of the block. I'm going to make sure that none of them shavings ended up anywhere where I don't want them. This is key to not having a problem with the motor. Another note, right on the tab here, they give you what is what. So they give you the part number and which ones it goes in. So CHP 251T is position 1 and position 5. 2 is 2 and 4, and 3 is 3. Just like what I said about the other bearings there. And generally, they have them in order. So if I hold the box this way, it's going to be exactly that way when I put it in. But you always have to check just in case somehow they got swapped. And when you do this, you always want to make sure the oil hole lines up with the oil hole down in the block. There is no true way to check the depth, so you just have to go off your better judgment. I'm using this pick and very carefully, it's not a very sharp pick, but very carefully putting it in there and checking the position of the oil hole to verify that the oil hole lines up with the hole in the block. I almost missed the oil hole on this one. I have turned just a little too far one direction. But it's still definitely in the oil hole, so don't have to mess with it. Something that needs to be checked when you do this. Okay, so you can't really see this that well, but if you look right here, see that little mark next to it, and then over on this side, there's one here, and then there's also one right here. Now those marks are from the cam install tool. If you get the tool just a little bit too crooked, it will destroy the bearing. And every time you install bearings, you need to try and feel that area, see if it's bulged up at all. If you feel a bulge, it's not the worst thing in the world. You can take a knife or a sharp edge or something and just kind of, the bearings are really soft, so you can just kind of cut them. But when I reset the tool and put it in that second time, I ended up with two little damage spots on the bearing, just like I was explaining. So with that, we're going to show you how to properly fix it now. So my tool choice is actually a super scraper. It's a very small one. Now all I'm going to do is make sure I'm tipped at an angle. I'm going to take the super scraper, I'm going to drag it at an angle across the edge. Now you see those two peelings that came off? Now that is fixed. It came off really easy. I did not have to do much. In fact, I'm going to go at a little bit more of an angle and just touch it a little bit more just to make sure that I got it all nice and cleaned up. Okay, there's that one. And there's a little bit of an edge right here. This is going to be a little bit trickier to fix. And a little edge on the top. So it must have went in just a little crooked, just enough to cause some damage. So I got all those edges taken care of. But as you can imagine, now there's some metal shavings in there. So I got to get rid of those. See the edge I cleaned up there? Now you see those little specks? Those are all just metal shaving pieces. See how they just fall off of there? So the coating of the bearing is in great shape yet. And I have no concern that this cam will rotate perfectly fine and not have any problems. Those are little metal filings. Now I got to get those out of this block. So now this last and final bearing, it gets installed differently only because the proper way to install it, if I were to use the installer tool, would be to go from the other side and come this way. Because the tool is designed so that this keeps it centered. That cone goes on here and keeps the bearing that is actually being installed centered, the shaft centered. That way you don't end up with those nasty marks on that spot. That's probably more so the reason I had marks. But I will go ahead and get this next one installed with my method that I use. Now when you place this in here, you can feel if it's crooked or straight. You can kind of feel it, so you just get it as straight as you can. And then I use a flat block. In this case, iron. Aluminum works fine too, whatever you have laying around that's nice and flat. Now the nice thing about installing it with that is I don't have any damage done to the bearing, and it is installed really nice and clean, and I can line up the hole really well. I don't have to worry about that thing being in the way of visibility. Now I can put away the cam tool. Okay, so you can see what I did there. I took the time to cut this thing, and I had to sit there and be very, very patient. It takes time without the proper tool. So the tools that I did use, which are not correct, are as follows. I got a super scraper. I only used that for the corner to create a mark on the crankshaft, so I knew where to put the keyway. I'm lining it up with the other keyway. And then I used this chisel that I custom made and custom hardened specifically for chipping harder metals, and I used it to hog out the beginning of it. That way when I use this, I would be able to use that chisel mark as a guide to a stopping point so I could feel where I was at and be able to grind down. Now when I use that, I started with a bigger wheel to hog the majority out, and then all I'm going to do now is just take a little emery cloth and touch it up. Now I'm going to clean out the crank. Then I have to clean the floor again before I can continue my assembly. Alrighty, you can see I have some bearings. I have a crank, I have a block. We're going to start assembly finally. Now everything has been measured already. I have the machine shops do their measuring, but of course we have to double check their work. The bearings are supposed to be 10 thousandths, and I gotta make sure I ordered the right parts. First thing I gotta do is take these things out of the package and lay them down. I have to lay the upper and lower in place, so the uppers go on the block, which is confusing because you have the block upside down. A lot of mistakes people make is they put the wrong bearing on the wrong side because the block's upside down. I've seen all too often where rod bearings are swapped. So I'm gonna go ahead and get started laying these in there. First thing you got to do is put all the bearings in dry. Of course, this is assuming you do not have the proper measuring equipment, like I do not. Just the bore gauge alone is close to $1,000 for the good quality one that one should have to do this. Being cautious not to put any fingerprints on the bearing itself. There is only one bearing that matters as far as its position, and it's the center bearing. Otherwise, it's only top to bottom for a difference. Now, you saw me clean this thing off, but wait till you see what I find with this rag, and then you'll understand why I'm doing this. This rag was white. Look at all the nasty color on here. This is all micro metal pieces. I mean, they're just super, super small filings of metal. And even after brake cleaning and airing it off as good as I did, it's still there. It's almost impossible to completely get rid of. The best thing to do is to manually wipe it off. Okay, so this was a nice clean rag. Now you can see it's covered in dirt. First thing I'm going to measure before I do anything else is the crankshaft end plate. Oh, there we go. That's better. Let's try that again. So it's at 7 right now. So they did do a little bit much on the end play there, but that's okay. It's still acceptable. I'm going to go ahead and get the plastic gauge ready. Yes, for the critics out there, I use plastic gauge. Believe it or not, plastic gauge, as inaccurate as it can easily be, it can be very consistent and reasonably accurate when used properly. I'm going to stress that heavily. It has to be used properly. And I keep this in a special spot because if you kink this too aggressively, if you accidentally set something on top of it, anything of that nature, it'll distort the plastic gauge. It has to be as perfect as possible in order to work. Another reason a lot of people fail to use it, if you cut it like this, it'll work okay, but the best results you can get out of it is if you peel it off and you cut just the plastic gauge with a razor blade, because this plastic gauge, it's a squish measurement, so it's a precision amount of material to get your desired result. When you cut the paper with it, it will squish the plastic gauge because it'll spread the weight across the paper and squish it. If it's a sharp enough scissors, it might be okay. I don't know. I just don't risk it. Now this is a nice, fresh razor blade, brand new. What I'm going to do is I'm going to cut 5, okay? Now whatever I do, I don't want to pull on it, because if I pull on it, it might stretch the plastic. Now we have our 5 pieces. What I need to do is set these on the crank. Okay, so a big mistake people make with plastic gauge is the oil the other side of the bearing. I laid everything on here flat or dry. It's not spinning fast, it's not running, there's no stress on it, it's not going to wreck anything. So what I need to do now is I'm going to get the plastic gauge laid out. So I need to turn this thing so I have spots where there's no oil hole on all of them, so I can do them all at the same time. I'm going to turn it just a little bit. Another mistake people make with plastic gauge is they use their hands to put it on there. Honestly, if you don't touch it, you're going to get a better measurement. So razor blade, and you just barely touch the edge of it, and you can grab a hold of it. Then you just use your finger and real cautiously touch the edge of the plastic gauge against it. It'll drop down. It takes a little finesse, but once you get used to it, it's not that hard. The one nice thing about a plastic gauge over a bore gauge is if for some reason you had some kind of piece of material caught underneath the bearing surface, and you had removed the bearing surface at one point, you wouldn't know with the bore gauge. Okay, now like any of the ERP stuff, it comes with a torque sequence and the torque amount. So we have 2 different torques. We have an inner stud of 60 and an outer stud of 50, and then the little side pieces are 20, and then the windage tray nuts are 28. So there's the pattern. It's a cross pattern. So I'm going to go ahead and do just this section here. I'm not going to put the side bolts in because all I'm doing is the plastic gauge. So I'm going to start with the inner studs at 50. So I'm going to do 50 on all of them, and then I'll come back and I'll hit the inner studs at 60, and then I'll take it all apart and check where my clearances are. Okay, so you can see the mark there from it. That's the rod. There's another one. Barely see that one. See that one there. There. And there. Now, I'm going to bring you over to the caps because they tell the same story and they're a lot easier to read. Okay, so you see the size ranges there. This is in thousandths of an inch. So let's go ahead and see what they are. 1.5 thou. That's in between the two, so it's probably like 1.8 if you were to 0.8 thou, I guess. That's a little more than a thou or 1.5 thou. That is 1.5 thou. 1.5 thou. So, what I want to point out is look at the consistency of these marks. Most Plasti-Gauge, if you do the Plasti-Gauge incorrectly, they will be inconsistent. So, like this mark here, it might show. Actually, this one's a good example. This one's not very consistent. You can see it's wider right here than it is right here by a little bit, but you will see it'll look a lot worse if you screw up the Plasti-Gauge. So what will happen is you might have it like really wide here and then squished there, and then or narrow there and then wide out here, or you might have it a very bad taper. That would probably mean you got your cap on wrong. But if this is super uneven in any way, shape, or form, you have to figure out why. First thing to do would be to put another piece of Plasti-Gauge on there and see if it changes, if it's any different. If it consistently measures the same, then you have a problem with something with the motor. If it changes after you put Plasti-Gauge in on, you did the Plasti-Gauge wrong. Plasti-Gauge is a very, very touchy product. If you screw it up, it's easy to screw it up. It won't read properly. Now I have to clean the Plasti-Gauge off of here and start my assembly with some assembly lube. So this stuff here, this Salukis assembly grease, this stuff is incredible. It works really well. It feels amazing. It just seems like a really good quality product. When you're doing the main bearings, don't forget the thrust bearing. You gotta make sure you lube that. If you don't lube that, it'll wear out on first startup. Alright, hopefully you enjoyed this video. I'm trying to get into a bit of the details on it. There's still a lot of details I'm skipping over because it just makes for far too long of a video. If you like this video, be sure to like, share, subscribe, and as always, thanks for watching, and I hope to see you on the next video.